In this video we're going to look at how to calculate a regression line of the form required for the S1 examination. So everything you need here really is in the formula book. So this is the page of the formula book that we require, and it tells us here the least squares regression line of y on x is y equals a plus bx, where a is equal to y bar minus bx bar and b is equal to sxy over sxx. So they're the values that I'm going to need, so y bar, x bar, sxy and sxx. Now the set of data in this particular question is the same as in the previous video on product moment correlation coefficient, so I'm just going to cheat and use some of these values from here. So the ones that are going to be useful are when I needed sxx and sxy, so related to the h and w I've got here. That means I need shh, which we calculated before to have a value of 996.875. I need shw, which we calculated to have a value of 713.75. And if we did need to calculate these values as well, it's relatively easy. The formula that we require are in the formula book. And we also needed x bar. So x bar is the mean. So in order to calculate the mean, I need to know the sum of the data. So x bar, in this case, is actually h bar that we want. So h bar is going to be sigma h over n. So that's 135, which was our value of the heights added up, over 8. And then w bar is similarly the mean of the weights here, so that's going to be 590 over 8. So these are the values I require. So what did I need to calculate? Well, b is equal to sxy over sxx, so this is equal to 713.75 over 996.875, and I'm going to work that out as a decimal as well. In fact, I'm just going to write down that fraction as well, because when I'm calculating a, I need the value of b, and this is going to be more accurate than my decimal answer here of 0.71598, so on. I'm going to do this to 4 decimal places, so 7160. So the value of a is then y bar minus b multiplied by x bar. So it's going to be 590 over 8 minus 1142 over 1595 multiplied by 1135 over 8. And at this point I'm not worried so much about having an exact answer, because this is the last calculation I need before I'm going to write down my answer, and generally speaking for this topic we want to be giving our answer to about 4 decimal places. So I've got here negative 27.8307 to 4 decimal places. So now I can calculate my, or I can write out my least squares regression line. So I've got w is equal to, so it was in the form here, a plus bx, so it's negative 27.8307, add and then bx, so 0.7160, not x, sorry, h. Quite often you can be asked to comment on what the values of a and b actually represent. So b would represent the increase in weight for each increase of 1 for height, and this would represent the height, the weight for somebody with a height of 0, but obviously contextually that's inappropriate, which leads us nicely into the next question. So can we estimate the weight for particular heights? So yes, we can is the answer, and it's relatively easy. I'm just going to substitute into the equation. So the weight, first of all, I'm going to substitute in the height of 155. Give me this as an answer. And that would be for the weight. Does that seem sensible? Yeah, that does seem sensible. That's not too different from the higher numbers that we got in the table before. So comment on the reliability. Well, this is reliable as was obtained through interpolation. And what that means is that the given value that we had, 155, was within the range of the data we've got here. So anything between 126 and 160 that's the data range we've used to calculate the regression line. So anything within there should be a reliable estimate. So then we move on to the second bit. So when we use our second estimate, this is going to be less reliable because 165 is out of the range of values we had, and we call this extrapolation. Doesn't mean it's wrong, but there's no data to back it up. For all we know, there's a sudden change after 160 centimetres, and the regression line we've just calculated is no longer appropriate. But we don't have the evidence to back it up. Now this is only just outside the range, so actually it's probably fine. But we need to say this is not necessarily reliable, or this is not reliable as it was obtained through extrapolation.